All right, so here's the equation we're going to solve with our cops and robbers that we can't just separate individually like this. So when trying to figure out which part of the equation is going to be the cops and which one's going to be the robbers, we have an acronym that is LIATE that stands for logarithmic and natural log. We have inverse trig for the I. We have algebraic for the A. We have regular trig for the T, and then there's exponential for the E. So based on what we have in our original equation, we're going to start with the L because we have a natural log. So we're going to make this the cops. So the cops, we're going to make a U, and it's going to be the natural log of X. So then when we take the derivative of this to separate them from the group, we get 1 over X, and then dx for the derivative. So that means that the x squared is going to be the robbers. So we're going to make them dv already because they're the bad guys. They're going to be x squared. So then we're going to take the antiderivative to make them good and separated, which means we're going to raise this up by 1 and make it a 3. And then the 1 that's here is going to be divided by 3. So our antiderivative is going to be 1/3 x cubed. So now the formula for integration by parts is going to be VU minus the integral of V times the derivative of U. So using this and our information down here, our new equation is 1/3 x cubed, natural log of x minus the integral of 1/3 x cubed times 1 over x dx. So then to simplify this, we're going to divide this by x, and we're going to end up with 1/3 x squared. And we're going to get 1/3 x cubed natural log of x minus, we can take out the 1/3 in the front and get 1/3 the integral of x squared dx, which is the same thing that we did up here. So it says 1/3 x cubed times the natural log of x minus 1/3 times 1/3 x cubed plus c, which is 1/3 x cubed times the natural log of x minus 1/9 x cubed plus c.